Hello students, welcome to the channel. Thank you for all the messages that you have been sending me about the content of the channel. I'm glad that you guys like it. Today we discuss the fifth reading passage of the October 16, 2019 PSAT. We have already discussed the first four passages of this test. And I've also uploaded videos for the writing and the math sections, so do check them out. This passage is adapted from Rachel Newer. Via plant releases its pollen. Via plant, right? I think that's the pronunciation. Via plant releases its pollen by the light of the full moon by the Smithsonian Institution. Ephedra Femina is a Mediterranean shrub. Ephedria's relatives, which first arose about 130 million years ago in the early Cretaceous, likely served as dinosaur food. Like others of their kind, ephedra plants don't have flowers and instead secrete droplets of pollen-laden liquid from their cones. Some species let the wind ferry drops between cones, but the liquid is also high in sugar, which attracts insects. So this paragraph basically provides a basis to the passage, like a sort of introduction, where we know that the relatives of this plant called ephedra, which the passage tells us is a Mediterranean shrub, the relatives of this plant, they first arose 130 million years ago and served as dinosaur food. They don't have flowers and instead secrete droplets of pollen-laden liquid from their cones. And some species let the wind ferry drops between cones, but the liquid is also high in sugar. So the transmission mechanism is either through wind or through insects. Katarina Ryden, a botanist at the University of Stockholm, suspects that ephedra might have saved itself from extinction by shifting from a predominantly insect-pollinated system to one dependent on wind based on observations she has made in the fossil record. So here we are talking about a possible reason why ephedra is not extinct, because it shifted from an insect pollination system to one dependent on wind. Historically, climate change has occurred repeatedly, not least in the aftermath of the meteorite impact 65 million years ago, and wind pollination may have been a safer method to ensure reproduction during such times. It is thus possible that insect-pollinated species of ephedra had a greater risk of becoming extinct. So here we talk about the possible impact of climate change and the dying of species on pollination of ephedra. And so species of ephedra that relied on wind for pollination were more likely to survive than were species of ephedra that relied on insects, because some of those insects may have passed away, may have gotten extinct due to climate change. To better understand the plants and their evolution, Ryden and her doctoral student, Christina Bolender, headed down to Greece, where they scrambled over rocks to count insects and keep an eye out for pollen droplets. They had already determined that E. distachya, one of E. femina's close relatives, sent its pollen riding on the wind, a finding that matches most other ephedra species researchers have taken the time to study. But E. femina's pollination methods remained more elusive. Even after its cones appeared, they refused to open, and the usual suspects among insect pollinators seemed uninterested. So here we are looking at two species, two ephedra species, where E. distachya or distachya, whatever the pronunciation may be, that depended on wind for pollination. But E. femina's pollination methods were not clear, right? So that is something that needed to be studied. One night over a Greek dinner, the two began musing about something they had recently read about nocturnal insects using the moon to navigate. Suddenly an idea struck: could E. femina's pollination somehow be connected to the lunar cycle? It started as a joke that evening, I should say, Ryden says. Still, the joke seemed plausible enough that she and Bollinger decided to investigate. They eagerly bided their time in the field, reading up about nocturnal pollination and counting down the nights until the July full moon. On that long-awaited evening, the researchers strategically positioned themselves in an open field of E. Femina and waited. As the moon rose in the cloudless sky, its soft glow revealed droplets of pollen which shimmered and sparkled on the brightly colored cones. We may be biased, but we found it ever so beautiful. So this kind of describes a hypothesis that they were trying to test whether the pollination of E. femina was connected to the lunar cycle, right? If the insect pollinators were attracted to this on a particular day, depending on the lunar cycle. And so they readied themselves for a full moon night and they prepared. Whereas most nocturnally blooming plants have white flowers to help pollinators find them in the dark, E. femina's cones are red and yellow and they emit no discernible scent. It became clear to us that the glittering probably is the means of nocturnal attraction that we had searched for but not found before. That display likely acts as a homing beacon for insects, including the flies and moths that the researchers observed alighting on E. femina that evening. So they found that the droplets of pollen which shimmered and sparkled on a full moon night, that was perhaps the only way of attracting the insects in the night, because normally nocturnal plants, the ones that bloom nocturnally, they have white flowers which E. femina doesn't have, or they have really strong scents which again E. femina doesn't have. So the glittering pollen was perhaps a way for the plant to attract insects. Although the light of the half moon would likely be sufficient to illuminate the pollen, the full moon alone remains up throughout the entire night. So the researchers think that E. femina maximizes the effect for efficiency. Only at full moon do the insects have a moon to navigate by during the entire night. So the time span becomes a factor with the full moon. And it is only at full moon that can the entire night in a way be used for pollination. So far, the researchers only have that one spectacular display backed up by a scattering of historical data that seems to support the pattern. While some pollen drops did appear during the full moon of August and September, there were significantly fewer cones, suggesting that E. femina, like its relatives, peaks in summer. As such, many mysteries remain. Okay, so we'll come to the graph later. Let's get to the first question. 39, right? Based on the passage, what led Ryden and Bollinger initially to hypothesize that E. femina pollination is in some way connected to the moon? Fellow scientists recommended that hypothesis as a possibility. They noticed a decrease in daytime insect activity during a full moon. Other researchers had linked nocturnal insect behavior to the moon. They observed a reflective quality in the pollen. So it's very clearly C, right? Because we know that when they were together having that dinner, one second, I'll just move this a little down. Yeah. Okay, so when they were having this dinner together, the two began musing about something they had recently read about nocturnal insects using the moon to navigate, right? So they had read up about it. So that's like 35 to 37, right? So they had read about other researchers, lines 35 to 37. Okay. I'm looking for that other tool that, the other tool that does not just like reproduces what you write. Okay, and the passage suggests that Ryden and Bollinger might have had a biased perspective during their full moon observation because now the biased here comes from here, and the biased perspective obviously comes from the fact that they study it on a day-to-day basis, right? They were happy because it seemed that their hunch was about to be confirmed, regretted their inability to find a pollination source, appreciated the way the light from the pollen droplets helped them to identify the insects, were anxious to share their discovery of a new pollination method. So you can see that A would be the best answer here, because the fact that the pollen was shimmering in the full moonlight, that was something that could prove that what Bolender and Ryden had hypothesized would be correct, because that shimmering would attract insects, right? Because we know that E. Femina does not have all the characteristics of nocturnally blooming plants. So the fact that it was glittering and glimmering was a good sign that it could attract insects and prove their hypothesis true. So when they say that we may be biased, but it was extremely beautiful, it was because their hypothesis was about to be proved correct. Based on the passage, what is the most likely reason E. Femina's pollen display does not occur during the half moon? The half moon is not bright enough to aid the insects in navigation. The half moon interferes with the insect's daily cycle of activity. The half moon is visible for fewer hours of the night than the full moon is. The half moon does not have the gravitational pull of the full moon. So it's C, right? We know it's C because we have studied it here, that the light of the half moon would be sufficient to illuminate the pollen. So brightness is not a factor. The full moon remains up throughout the entire night. So it gives E. Femina a chance to spread its pollen over a greater time span, right? So that's what C is saying. The half moon is visible for fewer hours of the night. The main effect of using the phrase shimmered and sparkled and the word glittering to describe E. Femina's pollen drops is, so you can see it's here. The pollen drops shimmered and sparkled, and that the glittering probably is the means of nocturnal attraction, right? So what's the main effect? Explain why the droplets were functional in spite of an unpleasant odor. Pinpoint a result of evolutionary change since the early Cretaceous period. Hint at why scientists were driven to discover Ephedra's pollination process. Provide a vivid description of the qualities that attracted insects to the droplets. So it's D, right? Because we know that they were studying why insects were attracted to E. femina. And we know that option A is not correct because they are odorless. They don't have an unpleasant odor. They don't have white flowers to guide insects in night. So the reason the insects were getting attracted was because of this shimmery nature of the pollen, which reflected the light of the moon. So to use these words, right, to shimmer and sparkle, is to give a vivid description of that process. So D is the answer. As used in line 72, backed up most nearly means. So if you go to line 72, it says, so far the researchers only have that one spectacular display backed up by a scattering of historical data that seems to support the pattern. So backed up here would mean supported by a scattering of historical data. So I'm looking at, it's not reversed, it's not blocked, and it's not substituted, right? It's reinforced. Their spectacular display is reinforced, is supported by historical data. So it's B. Which statement most accurately describes E. femina's pollen drop production as depicted in the graph? So now we can look at the graph. If you look at 2011, on full moon, it was at the peak on 15th July. And peak pollen drop production was a day before the full moon, right? So in all these cases, 2011, 12, and 14, peak pollen drop production was a day before the full moon, right? We don't have that data for 2013, right? So it peaks shortly before the full moon. That seems to be a good answer. And that also makes sense because if the pollen production peaks shortly before the full moon, then on the full moon, the insects would be able to carry that pollen around, right? So A is a good answer. It peaks shortly after. That's not correct. It peaks at exactly the same time each year. That's not correct. It peaks at different times among various populations. So we are not looking at various populations here. So the best answer is option A. Which findings shown in the graph supports the passage's assertion that E. femina shares characteristics with some Ephedra species? So it shares characteristics with some ephedra species. Okay, let's look at this. I'm actually interested in these evidence lines first. So let's read line 3 to 5, 26. Okay, let's go to 3 to 5. Like others of their kind, ephedra plants don't have flowers and instead secrete droplets of pollen-laden liquids from their cones. Okay, so that is 3 to 5. What about 26 to 30? They had already determined that E. distacha sent its pollen riding on the wind, a finding that matches. Okay, so I don't think there is evidence for that here because this is about how, yeah, that I don't think that is relevant here. 43 to 46. 43. They eagerly bided their time in the field, reading up about nocturnal pollination and counting the. So this is not about other other species. So I'm definitely sure that C is out. And 74 to 77. While some pollen drops did appear during the full moons of August and September, there were significantly fewer cones, suggesting that E. femina, like its relative, speaks in summer, right? This is a good point of similarity with its relatives, right? So let's look at this. E. femina's peak pollen drop production coincides with full moons. E. femina's peak pollen drop production occurs in July, and we see that happens, right? That happens. Peak pollen drop production has occurred in July for these 3 periods, 3 years out of 4. The timing of E. femina's peak pollen drop production varies from year to year. The association of E. femina's peak pollen drop production with the full moon has become weaker over time. So we know that it happens mostly in July, end of June, July, and it goes with the fact that while some pollen drops did appear during the full moons of August and September, there were significantly fewer cones, which means it peaks in summer. So I would say B for this and D for this, right? That's the best answer. Okay, so let's grade this. We start from 39. I have the answer key here. 39. CBACD, CBACD, okay. BABD, BABD. Okay, so we got all correct. Right, so that finishes the solutions for the October 16, 2019 PSAT. I'll group all the videos and put them in a playlist that I would link to in the description box. Let me know what other videos you'd like me to upload. I'll see you guys soon. Take care. Bye-bye.